Hello everyone, my name is Elif. I am joining you from Turkey, where I live in Kahramanmaraş. I'm currently an 11th grade student at Çukurova Electric Anatolian High School. Today, I'm excited to present my project titled Beyond Rote Memorization, Catalyzing Scientific Curiosity with Artificial Intelligence, or simply AI-powered chemistry. Today, I will present a project that sits at the intersection of two fields. First of them is artificial intelligence, and the second one is education. More specifically, I will describe an approach I developed to use artificial intelligence to teach chemistry concepts to young children. In this presentation, I will begin with a short introduction to the purpose of my project. Then I will share the background, explaining why traditional rote memorization limits scientific curiosity. After that, I will present my approach, which focuses on using artificial intelligence to make chemistry more engaging and meaningful. Finally, I will highlight the benefits. Why did I choose this topic? Last year, I placed third in the regional TÜBİTAK competition in chemistry category. That experience increased my interest in chemistry, and it also made me notice a serious problem. Teaching chemistry to young children is often difficult. And another reason is recent change in our national curriculum. In the past, most chemistry topics were introduced in later in school, when students were older. But in recent years, our national curriculum has changed. Some topics that used to appear in higher grades are now taught much earlier. As a result, younger students face concepts such as molecules, bonds, or even reaction types before they are ready to fully understand them. And many students then think, chemistry is too hard for me, and memorizing can help pass in tests in short term, but it doesn't create lasting understanding. If a child believes science is fun, interesting, and understandable, this belief can last for a lifetime. Now, I'll move to the background section where I describe the curriculum change, current teaching materials, and the educational problems that motivated this study. My aim is to help solve this problem by giving children a strong foundation in chemistry from an early age. If we can introduce basic chemistry ideas with age-appropriate visuals, rhymes, and playful names, children will not struggle later when they meet more complex topics. This is where AI becomes useful. Artificial intelligence can help us produce child-friendly images, create short rhymes, and suggest simple nicknames for elements. Visual generation tools can turn abstract concepts into concrete images. With AI, we can design many different materials quickly and adapt them to the different aids. In short, the background of this project is curriculum changes are creating earlier exposure to difficult topics. Current teaching methods rely too much on memorization. At the same time, we know early science education is highly important for long-term development. And in this part of my presentation, I will describe the process. The central idea is to use artificial intelligence as a tool to create child-friendly chemistry materials. These materials include three main types. First of them is visuals. It's including simple and colorful images that explaining abstract concepts. Second one is rhymes. It means short and rhythmic sentences that make terms easier to remember. And the third one is nicknames, like playful and age-appropriate names for elements or chemical ideas. For young learners, abstract chemical symbols are often confusing. AI image generation tools can transform these symbols into characters. These visuals aren't random. I use prompts that are age-appropriate, simple, and safe for children. After generation, I carefully checked each output. Some of them weren't suitable, so I improved them with tools such as Photoshop. In this way, the final image became clear, consistent, and fun. And let's talk about the visuals. First of them is sulfur, is abundant and highly valuable. It's a bright yellow, crystalline solid at room temperature. And it's the fifth most abundant element on Earth. It's widely distributed in nature, which is why its reverse side is depicted in yellow with a mine theme. Magnesium is a silvery white metal, and it's usually usually using by being alloyed with other metals. It is one of the lightest metals and has gained importance due to this property. It takes part in more than 300 essential reactions, such as energy production. For this reason, and because of its lightness, it has been depicted as floating in air. And nitrogen is odorless, colorless, and a light gas, which is why it's illustrated in this way. Aluminium is light and strong, and pure aluminium is soft and has workability, which is why it has been picturized in a factory. And there is carbon tetrahydride. I connected it with 4 lines because carbon can make 4 bonds. And last one is phosphorus. Pure phosphorus can be found in red form, so I showed it in red. Since it can be found in minerals and is an important element for life, I depicted it in a living environment. And when I gave prompt to the AI to picturize the element phosphorus, it generated an image with 8 arms. This result was due to phosphorus being able to form 3 or 5 bonds. And I made adjustments to the image, and in this way, I ensured the accuracy of the elements. And creating rhymes with AI. Rhymes are powerful tools for memory and phonetic awareness. I used AI language models to create short sentences that describe elements or bonds with rhythm. For example, instead of saying only carbon makes 4 bonds, a rhythm can be Captain C makes 4, never less, never more. This rhythm helps children remember and also improves their pronunciation. And creating names with AI. Nicknames makes chemistry more personal. For example, instead of calling helium only He, I introduced it as the happy balloon, and AI helped me generate many possible nicknames. I then selected and adjusted the ones that were simple, easy to say, and connected to real properties of the element. These nicknames turn abstract facts into characters that children can imagine. And AI make it possible too, generating large amounts of creative content quickly, personalizing materials for different age groups, provide teachers with flexible tools that can be updated easily. At the same time, human input is very important. AI can create options, but the educator must decide which ones are correct. I always checked and edited the AI outputs to make sure they were safe and meaningful. And let's talk about the benefits of this for children. One of the main advantages of the method is the positive impact on children's thinking skills. By combining visuals, rhymes, and nicknames, children can understand abstract concepts in a simple way. This approach helps them, and they can easily recognize patterns, connections, and relationships between elements. It may help to develop problem-solving and reasoning skills. They can remember information easily than traditional memorization. And repeated patterns may improve phonological awareness. This can contribute to reading and speaking skills, even outside the chemistry. And rhythmic patterns can help memory and fluency. Children can explore ideas actively, they can enjoy learning, and they can feel confident. Teachers and schools also benefit. AI-generated materials save time and effort, and visuals, rhymes, and nicknames can be adapted for different ages. Teachers can choose and edit materials according to the classroom's needs. To sum up, the project not only teaches chemistry, but also supports general language development. And I highly respect Sonia Tverdi's work and would love to meet and collaborate with her. Similar to her research, my project involves linguistics and creativity and cognition. Therefore, I will be delighted to have the opportunity to work with her in the next stage. Thank you very much for listening.